Most of the time, we have observed the need of the remote I/O configuration with the PLC, and there we uses the bus coupler, which connects with the PLC utilizing different I/O configuration. Here, I am going to show you how we can commission a bus coupler of Wago into the codices and how we can configure it to be getting utilized. So, the first part is power up the coupler. So first is in the commissioning step we need to power up the coupler, and then we can go and configure it for the next purposes. So once the Wago bus coupler has been powered up, then if you are seeing, we have the dip switches settings. So in the dip switches settings we can configure the IP. So whenever it comes with a default IP of 192.168.1.0. Now we need to set the IP using the dip switch. So if you see, we have a number given. So on one side it is off, on another side it is on. So right now I have made on to the number 1 and 2, which means the IP which I have set it is 3. Okay, then I will connect the Ethernet cable on the Wago bus coupler and this other side on the IP our PC. Now utilizing the IP which we have set, okay, 192.168.1.3 right now. 1.3 is the IP. We can be able to go online with the web server management. Okay, from here, once we have configured the IP and we are able to go up with the web server management, we can log in using a credential that I will put in the description. So this is the default, comes with any Wago bus coupler, and then we can be able to go into the different configuration mode to set the IP, to change it from configuration to DHCP, static IP. All the configuration we can be able to access from this particular web management service. Okay, so I will go walk you through different configuration, how exactly we can configure the DHCP, how we can configure static, how exactly when we'll forget the IP of the system, how again we can recover it. So what I'm trying to do here is I'm trying to connect a serial cable. So this, the black one which you are seeing, that is a serial cable. So that is one of the easiest method to do the configuration. And I have opened the Wago Ethernet setting, and here I will be able to connect using serial cable to the Wago bus coupler. So this is I'm doing to show you all the different step, how exactly it is behaving in the background of the bus coupler. Okay, so once through the serial cable also I'm connected, you can see here that it will show here currently used configuration and what is in the edit mode configuration. Okay, so these are the two different options. So currently used configuration which is showing is the exactly configuration through which we are able to connect. So if you see, currently used right now is dip switch, because initially we have set the dip switch, and the IP which we set is because we have made the dip switch 1 and 2 into the on state. So the IP it is showing here also 192.168.1.3. Okay, so let me just make this coupler a little more visible. Now, whenever we have set this particular IPs, okay, in order to change the configuration, so as we have set in the edit as a DHCP server, we need to reboot or recycle the power of the coupler. So once the power of the coupler get recycled, okay, now if I read it back again here, because our in the edit mode we have set it to the DHCP, if we can see that the currently used has changed from dip switch to DHCP server 192.168.1.11. So I have a router, so which I have connected now the cable of the coupler, so which it is getting the IP. Now the web management server service I need to open on the IP number 11. Okay, so in this way we moved from the first stage, from a dip switch setting to the DHCP server. Okay, so from here also we from this particular tool also we can be able to edit the configuration, but mostly we will try to do it from the web service management. Okay, so now I'm setting here the static IP, and I will give here the IP address. So any IP address based on your need we can give. So I'm giving here 10.20.60. dot triple one. Okay, and subnet I will keep the same. So once I click on the submit, it will ask again for the user and password, so that we need to provide, and then it will get configured with the static IP. Now, right now, if you are seeing here, it is on the Ethernet setting tool, it is showing still DHCP server in the current as a currently used. Okay, so every time whenever we do any change in the setting, we need to always recycle the power of the coupler. So let me first read it. So before doing the recycle of the power, so you will be able to see here what exactly is in the edit configuration. So if you see the edit configuration change to static, and what is currently used, it is still in the DHCP server. Okay, because we have not recycled the power. So once I will recycle the power, so I just disconnected the power and let me connect it back. So the power recycle is happening. Now again, when I read it back from using the serial communication, then this particular tool will show that what is right now the currently used configuration. So in this manner, basically the serial cable is utilized mostly for uh, easy purpose. Okay, so we can even visualize what exactly is happening. So that is what I'm trying to show it here. So now if you see, the currently used has changed from DHCP server to static configuration, and the IP which we have set, that exactly is showing. Now we will not be able to connect because I don't have right now connected the cable into my laptop and don't configure the IP in this range. So right now still it is on the connected on the my router. So now, for example, we forget this particular static IP. Right now you're able to see it here, but for example, you forget the IP. How again you will reset it? So to reset again, we will change the dip switch setting. Okay. So once we change the dip switch setting to on, so like 1 and 2. So right now I'm only setting the number 2 as on, 1 I have kept it off. So the IP will be 192.168.1.2, on which I will be able to read it. Okay, from the dip switch setting. So now if I read it back through the serial cable, if you see, the dip switch setting has been changed to 1.2. Okay, so as per the dip switch setting, whatever we have done. Now, as I told earlier also, we need to recycle the power in to get into that mode. Now every time whenever we're recycling the power and utilizing the dip switch setting, when we want to go and configure it. Okay, so right now let me read it first. So right now if you are seeing, I'm getting that it is not available. Why it is showing? Because the connection is still with my router, so I need to change my connection and I need to put it on the local network. Okay, so serial communication is still showing that it is connected, but my cable is connected to the router, so it is showing no configuration. So sometimes that is where the serial communication come in picture, and it is good for the troubleshooting part. Okay, that we will get exactly what is the issue and we can be able to troubleshoot. So let me connect it into my laptop and configure the IPs, so that we can be able to access it. So now I have connected the cable to my laptop, and let me reboot. So we will not be able to see the image because I have been moved out of the router configuration and not on the internet. So now if you see here, right now it is not able to access. Let me reboot the configuration and read it back. So now once we read back, it is rebooting. So it will come on the 192. So current configuration showing dip switch setting as 1.2, and my web management service is running on 1.2. Okay, so in this way, if we have forgot the static IP, we can be able to reconfigure using dip switch, and again we can go back and reset the IP and everything using this particular method. Okay, now we can again reconfigure it for the DHCP part. So let me do that. So it will be easy for me to do all the configuration and show how exactly it get worked. Okay, So this time what I will do, I will configure. So yeah, I have set it and then I to DHCP and then submit it so that it should get the IP from the router and we can be able to communicate properly. So even I can set it from here and click on the right. So either way we can do. Okay, so from this tool also and from the web service also we can be able to configure it. So if you have the serial cable, or even we can utilize the tool, and if you have connected to the Ethernet also and want to use from the web service management, then also we can do it from there. Okay, so now it will go into the DHCP mode, and once I read it, I will get the DHCP IP through which we can be able to again log into the web service management. Okay, so right now also it is showing 1.2 because I have not recycled the power. So every time whenever we are doing the configuration, we have to recycle the power of the coupler to get it working. So whenever you're seeing that you are not able to get it, just follow this particular step, recycle the power. Because after recycling the power, and once we have set it to DHCP or static, we need to set the dip switch back to the zero off position, means the off position. We should not keep it on because otherwise again after setting the DHCP or static, and if we again recycle the power, it will go into the dip switch setting mode, so you will lose the configuration. Okay, so now if you see, I have set it all back to off condition. All the dip switch settings are in the off condition, and I'm on the DHCP configuration. So I have got the DHCP IP. Now there are a lot of different features which are present in the web based management, from where you can do the configuration of the coupler itself. So like the clock setting you can do, so you can configure it as a NTP server or NTP client also, and set or the server configuration, the IP through which it has to synchronize the memory part. Then we, if you want to generate some error and log those things, that those configurations also are there in this particular. Okay, now to update the firmware, and now there are different protocols, correct? So like FTP protocol, HTTPS, Ethernet IP. So all those things we need to go and set it here. So if we have not configured, so it comes by default, but if you have not configured, we can go into the protocols and we can configure it here. From the tool, it will be almost similar, but few of the parameters are very specific to what bus couplers. So that is good to get it from the web service management. Okay, so those things will not be present in the tool mostly. Now configuration for SNMP for the email part, and then SNTP is there for configuring the NTP server. So these are the some of the features which also we can utilize on the coupler side. Okay, I just wanted to give you the glimpse so you can configure it based on your need. So most of the details will fall under Ethernet IP and then the IO data. So these are the main two config part where all the configuration regarding the bus coupler and the IO card which are getting connected will be shown here. So whenever we are doing the configuration, need to come here and we need to uh, check all the configuration which will we utilize to configure into the codices. So let's what we can do is, let me insert the card, IO card. Okay, and then we can see. So once I have inserted the IO card, now if you go to the Ethernet IP and see, right now I have not inserted, so I have just kept. So if you see, it is power is not on. So if we will see here that no IO mapping is present. Okay, so let me push it so that it should get powered up. Normally you should do it in power off condition. Okay, so that is what is suggested. So I have just inserted the card, and now let me just go back to the Ethernet IP and expand it again. So now if you see, I have added two cards and those two card details are coming here. So one card, first card is 1491 and another card is 491. So first card is two channel, so that is why you are seeing 8 bytes, and the second card is one channel, so you are seeing only 4 bytes. Okay, so here everything will show in the byte format. Okay, card details and the number of bytes it will take. So it is creating the process image. So basically we call it as a process image, which are getting created for the coupler into the for the IO cards. Okay, same thing in the IO data, it will show how many cards are connected. So if you see here, it is showing right now 2, because we have 2. Last card which you are seeing is the end module. So that is a dummy card which has no meaning. So it is just to give like it is end terminated basically. So that is the end. So now let me go to the codices, and there let's configure the first. We need to configure the Ethernet adapter. Okay, so Ethernet mod we have added, and then from the Ethernet we can be able to add the scanner, because we will be scanning the coupler into the codices part. Okay, so once the scanner is added, okay, now we will build the project, and then we will download it into the controller. So I have the Vago controller which is connected to the coupler. So let me just, okay, before that, yeah, we need to also configure the IP through which the coupler will be connected to the controller. Okay, so that we have configured. So we need to browse and select the port, and then we will download it. So once we have downloaded, now right click there and scan the device. Okay, so now if you see, it will scan the coupler which is already connected. So it takes some time. So now it is scanned, but if you see, it is giving also that EDS file is missing, so we need to install it. So how we can go into the web service management, into the Ethernet IP, and there we will find download EDS option. Okay, so that EDS we can download. So once this EDS is downloaded, then we have two options to install this particular EDS. One is directly by clicking here, install EDS file, or it will open the device repository only, or we can also go and click on the tool, and then click on the device repository to install this particular EDS. Okay, so when we click on the device repository, then again same thing will open, and here it will also show the same option. So let me again go back, because this is how normally we can do. It will be easy also that I'm scanning and then I'm installing the EDS file. Okay, so click on the install EDS and then go and click on the install, and then search for the module. Okay, so every EDS will have different module number. So whatever the module number you are having, just click on that and click on open, and then it will get installed. Okay, so this has got installed here. Okay, great. And now once it is installed, and when we click close this device repository, so it uh, so if you see here, it will come with the device description correctly, and then we can copy it to the project. So we need to click on the copy to the project, and it will get copied. So if we are scanning and adding, what is the benefit we are getting? That it will come with all the configuration, and even the IP will be the correct one. Okay, so we don't have to configure the IP. Now we need to configure only the assemblies and the, okay, so if you see here, there are different instances are given. Okay, so whatever we are going to use, that only things we need to select, and we can configure it into the connection. Okay, so first we need to click on the edit connection and number of bytes. Okay, so target to originator and originator to target. So these are like consumer and producer, that we need to configure based on the data what we have. So if you see here, analog input has 16 and digital output has one byte. Okay, so 16 and 1, so that is what is configured. And now instance number, if you see, I can utilize 109, 107 and 102, either of these three, because I have one DO card and one AI card. So what I will do, I will utilize the same. So I will configure it here by checking. Okay, so AI and DO. We can also check the raw data by clicking on the checkbox of raw data, that whether the instance number is correct or not. And then here, based on that configuration, the consumer and producer will get bytes will get created. Okay. Now here we need to provide and configure it for the IO mapping. So all the IO mapping will happen in the IO mapping part, and then we can be able to download. Okay. So let me, okay, before that, because we have to configure this IO mapping correct. So all the IO addresses I will put into the main task so that it will be configured as a consumed into the program so that it will communicate and show the data. Okay, so that's what I'm trying to do here. Let me download it. So download will take some time. So once it is downloaded, let me go into the run mode. Then we will see that we are getting some data on those addresses which we have configured. Why it is coming? Because I have configured here a 420 milliampere source on the analog input card on the channel 1. So that particular data is getting converted into counts, and that counts is actually showing it in the address on the IP part. Okay, so now let me give some command. So when I'm giving a command to the digital output card, it is connected to my simulation model for the lamp panel. Okay, so if you see, when I give command, the lamp get illuminated. Okay, so let me make it off. So I will make it 0, and then when I give again the command, the lamp will get off. Okay, so lamp is now off. Now as you are seeing right now, it is getting, I'm not giving true and false, but I'm giving is 0 1 2 3, because this is right now configured as a byte. So I gave number 2, so which means channel number 2, and then it is converting into bytes, and from bytes to bit, and then giving the command. Okay, so that is how exactly. So right now 3, so 2 lamps both get illuminated. Okay, so just change the position. Yeah, so if you see, both the lamps are illuminated. So in this manner, actually we can be able to control also through the remote IO, and read and write. So read the sensor data and write to the actuators, or the give the commands to the actuators. Okay, now another thing. So right now you are seeing that we are reading everything in the bytes. Okay, so let me show you how exactly we can configure or reconfigure it. Okay, so we need to go to the assemblies. Okay, where we are defining the producer and the consumer. So if you go into the assemblies, okay, then there we see that the signal which are created has been created in the naming of produce assembly and consume assembly. Okay, produce assembly parameter and consume assembly parameter. Now, and these are in the bytes, but if so, if you see here, these are in the bytes. I can change the name also, like digital output. Okay, so this, if you have to change the name for your better better uh, understanding purpose, so that you can be able to visualize, okay, this particular channel is for which output or which input. In this manner we can be able to change the names also. Okay, so as right now the analog input is coming with 16 bytes, you can see here it has a 16 number of signal configured. Okay, so what I will do, I will break that into 4. So if we have to break that into 4, then we need to also choose the different data type, correct? So different data type means either dint or real, which, so one dint consume 4 bytes. Okay, and one real also consume 4 bytes. So that is what we can utilize. If you are putting int, then yeah, it will go into the uh, 8 signals. Okay, so but I have to configure it for the 4. So in this manner, let me change the data type to dint, and then yeah, we can be able to convert into the 4th input only. Okay, so the counts which will come in to this particular channels will be in the dint, and that dint we can be able to convert it into our, basically into do the scaling and convert it into the engineering values. Okay, rest we don't need, so we don't have to read all the bytes. Okay, so in this manner we can be able to even reduce the size of, not the size basically, but the number of signals, we can be able to reduce it utilizing different data types. Okay, now here if you see, the same thing got updated, and the address is also now changed. from IB to ID. So that also we need to change it into the program configuration, where we were using earlier IB, that we will change it to ID. Okay, I will keep the output as byte itself, no change on there. Okay, and now let's when we have configured, and then we will need to download the code. So once the code get downloaded, and it will come online. So the code is downloaded in the stop mode. Let me put it into the run mode, and then we can see that once it is done, it is communicating, and then we can be able to see on the particular channel where I was earlier reading into four different bytes. I'm able to read only in the single uh, data type or single value. Okay, so we don't have to convert from byte to real or like that, but we can here also we can be able to convert from d into real, and all those things is still possible. Okay, but I'm getting that into a single variable, not into the four different variables. So that is what we can utilize to configure into the courses basically. And in this manner, we can be able to commission and configure the couplers. So this is applicable for all the couplers of Vago which are on uh, s- Ethernet configuration part, Ethernet port. For the serial and RTU, we need to follow a little different approach, but the process imaging and all those things remain same. Only the configuration with the uh, RTU will change. Okay, so I think last but not the least, one thing is that if we have already installed the EDS file, then when we scan, okay, we don't have to do anything. So it is already installed. So just click and onboard the device, and everything is there. But only the thing which we need to do is again the same thing. So all the assembly connection details and the uh, assemblies we need to reconfigure based on the card which are connected into the PL coupler. Okay, yeah.
Thanks for watching. That's all for this video. See you in the next one.